Okay, hello friends. Today we are going to discuss about the dealing with materials data collection analysis and interpretation, assignment number 8. So we'll start with one by one. We'll start with the first question. So this question: suppose you have ordered a certain kind of steel for which the manufacturer claims a strength of 150 MPa with a standard deviation of 5 MPa. Verify the claim that you want to test the hypothesis of mean is less than or equal to 150. Which type of hypothesis is this? Okay, so if you read the question carefully, they have given the average strength of the steel. The manufacturer claims the average strength of the steel to be 150 MPa and with a standard deviation. So it is known, the standard deviation is known, and so to test the hypothesis, first you have to understand the problem. If it comes to a steel, if you are having a strength of 150 MPa, it is always better if we have more but not the less. So the hypothesis here is the null hypothesis if it is less than 150. So it's the null hypothesis, but should not be less than 150, like we are testing for more than 150. If it is more than 150, it satisfies the problem. If it is equal or more than 150, it satisfies the problem. So that more than 150 is the alternate hypothesis. So we have to evaluate for the alternate hypothesis rather than null hypothesis. So here the answer is a simple alternate hypothesis. But we can understand like what is null hypothesis. Uh, for example, if light color has no effect on plant growth, so this is null hypothesis. It doesn't consider the consequence or the effect of the um, other constituent effects are not considered in the null hypothesis. The alternate hypothesis is light color affects the plant growth. So it consider the external factor which affects the plant growth or which affects the hypothesis is being considered as alternate hypothesis. So there is another one called composite null hypothesis. Composite null hypothesis is extensive because like it specifies a range of possible parameter values which can actually determine the hypothesis. For example, like here they have just told the light color, they didn't specify any value. If I tell like the light of wavelength 300 nanometers affects or 300 to 400 nanometers affects the plant growth means is more specific. That will come under composite null hypothesis. When you have more information to specify a hypothesis, it comes under composite null hypothesis. So here it is simple alternate hypothesis. Yeah. So going to the second question, there is a mass produced component of vehicle that should weigh precisely 250 grams. I think it's close to 250 kilograms, I guess. By mistake they have given 250 grams because a vehicle can never be produced at 250 grams unless it is a Mars rover or some small scale vehicle. Okay. So the engineers take a sample of this component and want to know if they meet specifications of weight. Which of the following option is or are correct cases of simple null and simple alternative hypothesis? Okay. So simple null hypothesis is, one second. Here for simple null or simple alternative hypothesis, this among all the four things you can see if it has some range or if it has some inequalities like less than 250, greater than 250, this comes under composite null hypothesis. So these are not simple null hypothesis. So and this is like simple hypothesis, simple null hypothesis, but doesn't have some, because they are defining like 250 is the mean value, and alternative also 250. This is not possible with alternative hypothesis. Alternative should contradict or should add more information to the null hypothesis. Yes, so here also we have inequality, so this also won't come under picture. So the answer is mean value 250 and mean value not 250. It's like a null hypothesis will set mu is equal to 250. That's what is given, and alternatively it will tell mu might not be 250. It might be more than or less than that. That extra information is not provided. So this is the answer. So going to the third question. According to WHO, RT-PCR test can indicate whether a person is COVID positive or negative. A certain level of accuracy. Imagine a person has been tested for COVID test, and the test report finds him, her, or him infected. The type on error in this case can be given as, okay. So this is a summary of the type on summary of the all the possibilities. You set a null hypothesis for this testing. So there are four possibilities. One is like the test may come true, but actually it may be false. So that is false positive. Sorry. Actually, the person may have some have COVID, but actually the person might not have COVID, but it will return the value true, like positive. That is false positive. If it is rejected, means if it is negative and actual the result also came negative, means it is false. It is true. Sorry, it is correct. And if it is uh, if the person is having positive, and if it comes positive, that is also correct decision. That is true. Okay, true positive means the person is affected. True negative means the person is negative and the results also came negative. So the fourth kind of is false negative. The person is tested for is actually positive, but results came negative. So whatever here the type on error in this case is given as actually the person is not affected. So this will come under type on error. Actually the person is not infected. The report says the person is infected. That is false positive. False positive comes under type on error. Going to the fourth question. A sample of size 20 is taken from a normal distribution with a known population. Standard deviation is okay. Okay. Then here the major thing which you have noticed is normal distribution with known population and known population standard deviation. We know the population standard deviation. So the sample mean is also given. Sample mean is 165. So null hypothesis is made for the population mean, so that the mean is 165. Against the alternative hypothesis, mean is not 165. Test will follow. Okay, since the standard deviation of the population is already known, and population was a normal distribution, this will comes under standard normal distribution. So if the standard deviation is not known, it will come under t distribution. So t distribution is a has a long tail as compared to the standard normal distribution, where standard deviation is not known in case of t distribution. And t distribution works in a way like with n minus 1 degree of freedom, which means like 20 minus 1, which is 19 degree of freedom. So in the same question, if the one word is like known changes to unknown, means it could have resulted in the t distribution with 19 degrees of freedom. But since the standard deviation, population standard deviation is given, it is in standard normal distribution. Yeah. Going to the fifth question. So suppose for hypothesis testing, the significance level is given as 0.5. So what is the probability of type on error, or probability of rejecting a null hypothesis when it is true? Okay, so type 1 error is already we have seen it is false positive. So type 1 error can be found outside the confidence level, like which is 95% of confidence level is generally taken, or 5% of significance level. So whenever the value is greater than the probability of or equal to probability of that error, so that is significance level. So that so the probability of type 1 error is same as the significance level, which is 0.5. So area under this curve from x bar to infinity. So going to the next question. A pharmaceutical company claims that its medicine has a mean active ingredient of 65 ppm with standard deviation of 9 ppm. So mean is given and standard deviation of 9 ppm is given. We have to test the hypothesis. H naught mu is equal to 65 against H alternative, which is HA. Mu is not equal to 85. 81 pills. The number of pills tested is 81. And the medicine is considered to pass the quality test only if the mean active ingredient in the medicine is more than 66.5. So the mean active ingredient, that's x bar. Okay, I've given x here. It's x bar is 66.5. So if it's if it is more than 66.5 only, like we can pass the test. So what is the probability of type 1 error? So in order to find the probability of type 1 error, we just have to find the probability of probability of type 1 error in the sense it's significance of significant level. We have to find it out. This is alpha. If you find out the alpha, it gives the same as type 1 error, probability of type 1 error. That is what previously we have seen here. So to find that, we know probability of x greater than the probability of z greater than or equal to greater than x bar minus mu naught by sigma divided by root n is equal to alpha. So we can find the probability of the standard normal variate that can give us this significant level. So how to find this? One second. First you substitute these values and find the standard normal variate value. So standard normal variate value is given by 66.5 minus 65 divided by what is sigma? Sigma is 9 into root 81. So this get cancelled, then it results in 1.5. The difference is 1.5. So the standard normal variate value is 1.5. So till here the value is 1.5. So find the corresponding probability from the table. So for 1.5 it is 0.9332. So it is 0.9332. So to find this region, it is very simple. It's 1 minus p of z. Equal to 1 minus 0.9332. So this will result in 0.0668. So the answer is given. which matches the given answer. So this is how we have to find. You just have to find the significance level that will give the probability of type 1 error. To find the significance level, first we are finding the standard normal variate and the corresponding probability. And when we standard normal variate means here till z we find it, and from the table we are getting the area under the curve. If you are if you are subtracting it with 1, we will get the significant level value alpha, which is nothing but the probability of type 1 error. Okay. With the seventh question. In question 6, consider the following scenario. If the mean active ingredient in the medicine is more than 66.5. Okay, mu is more than 66.5. Pills pass the quality test. Use the alpha as 0.05 and control whether the pills will pass the quality test based on the hypothesis. Okay, when the mu exceeds 66.5, what we can do is like it is exceeding the x bar will come under the 66.5. So whatever measured will come under 66.5. So it is like this. Whatever measured is 66.5, and whatever actual should be more than 66.5. So from the question itself, it is very clear that the data does not support the claim that the mean ingredient in the pill is greater than 66.5. Otherwise, even if you try to solve this problem, this will boil down to 0. I will tell you how it is done. So for example, you will keep the baseline as 66.5 and we try to solve the problem. When you try to find the standard normal variate, it will result in 0. So there is no probability of occurrence of this particular event. So the data does not support the claim that mean active ingredient in the pills is greater than 66.5. So that is the answer. Coming to the 8th question. If alpha denotes a significance level in the hypothesis test, then the confidence level is defined as, okay, significance level is this one, alpha. Okay, when it is a symmetrical curve, it is alpha by 2 on both the sides. Since alpha is equal to 0.5, here they have distributed as 0.25 and 0.025 and 0.025. So the remaining 92% area is the spread of the mean, spread from the mean. So this is called confidence interval. So how to find it? Simple. It's 1 minus alpha will give you this region. So answer is 1 minus alpha. Confidence level is 1 minus alpha. So coming to the 9th question. The critical region is a region of the distribution where null hypothesis is, okay, in the critical region means a region where which exceeds the confidence level. So when it exceeds the confidence level, it is generally the null hypothesis is rejected rather than being accepted. If it falls under the confidence level, it is accepted. So here, if it falls under the critical region, means it is generally rejected. It's rejected because it takes a lot of facts to accept a hypothesis. A simple negative information can easily reject a hypothesis. So going to the 10th one. If one wants to test the hypothesis H0, null hypothesis H0 is sigma square is equal to sigma naught square. So sigma square is a sample variance and sigma naught square is a population variance, which we have studied in the previous lectures with sample size of n. The test static will have actually we have studied before also the standard Sample variance is a unbiased estimator of the population of the population. So, and also the sample variance comes out from the population variance, population, which is standard normal distribution, um, where mean population of the mean is equal to population of the sample, whereas the variance of the sample and variance of the population are related to chi-square distribution with n minus 1 degrees of freedom. So similar thing is followed here also. Here we are relating with respect to sample and population variant. So the distribution, the statistic will follow the chi-square distribution with n minus degree of freedom. So rather than whatever we have seen, like normal distribution, standard normal distribution, or um, t distribution. Instead of that, here when we take this sample variance and population variance and as an hypothesis estimator, then it will result in chi-square. We have to use chi-square distribution with n minus 1 degrees of freedom to solve this hypothesis. Hope everyone is clear with whatever we have discussed till now. So if you have further doubts, you can contact me or mail me through the following mail ID which I am entering here. I hope all the questions must be solved in a clear way. If you still have questions, you are free to write to this mail ID. I will respond it as soon as possible.